So welcome back, everyone. We're so glad you're here. We set you up in a different way, but we're going to get started. So here we go. In the middle of your table, somewhere on your table, there's some math for you to do. So if you could get that little half sheet.
A teacher's day is never done, right, Fran? Now we got them doing math after school.
That's right. And here's what I want you to do. As you do the mathematics, everyone in this room, this is a SBAC released item from grade 4. When you do this, I want you to think about it with your teacher hat on. And I want you to think about what are some strategies that kids might use to show their understandings in this problem. Okay? You can talk to your neighbors about it too.
Oh, it's not a test?
No, it's not a test. So we're not going to throw this out for discussion. You were discussing because it's going to show up in a moment. So you're going to see something where we use this very exact problem, okay? So the discussion will be ongoing. So what we're going to do is we took a video a couple weeks ago of 3 Little Elk Grove 4th graders. And these 3 Little Elk Grove 4th graders could be 3 little 4th graders from anywhere in the state. But we wanted to start getting video of kids that are in your district. They could be my kid in 4th grade. They could be Kara's kids. Well, no, her kids aren't in 4th grade yet, so they'll be. But they are kids who are a product of a very procedural education, which all kids up to this point are. So we're going to show you this little video, and it's a good news video. It may start out where you go, I don't know about this, but it starts to be a very good news video, and we're going to talk about that. So what I'm going to do is I'm going to get it going. We're going to play around with the sound because, of course, I talk loud enough, and the kids, you'll pay attention to their papers as well as they're talking. And then we'll stop it from time to time and give you a little job to do, okay? I want to see what you're thinking. Okay, so go ahead and start, and we're just going to kind of watch. You can work on it by yourself. You can write on the paper. If you need scratch paper, I have some of that too. I just want to hear your thinking on, because you're all starting to sort them, and you're putting them in less than 1 or greater than 1. So I want to hear your thinking on this. So cap your pen. And who'd like to explain any of the ones you put? It looks like most, well, oh no, Taryn, you have one in greater than 1. So who'd like to explain one of the expressions that they put somewhere? And how do you know you're right? Or do you have a question even? Let's do the 3 times 1/2. Did you do 3 times 1/2? Okay, so all 3 of you did 3 times 1/2. So did you notice I was rapid firing questions? I wouldn't suggest that, but I was getting a lot of silence. And my questions were why, how do you know, why did you put it there? Now what you can't see is they did start to sort, and all of them sort of sorted similarly. I'm going to hone in on 3 times 1/2. So you see that one? So here's your job. And we're going to try and crank it because the kids are quiet. We want you to, who talks? Taryn talks, the 2 little girls talk. And what you have to do is try to write down numerically what they're doing. So in some sort of an equation, there's no wrong answer here, so don't get worried. But you're going to try and listen to them and write down what they're doing. Okay? All right. Yes. Equationally.
And you said 2 girls are going to talk, right?
Yeah.
And so I'm girl and girl. I'm getting ready to write it down?
Okay.
All right.
Yes, yes. And then what we're going to do to help you is Debbie's also going to write, and then Kim and Joe are going to copy her. So in this case, copying's okay. It's just so you can see everything, okay? So Cammie, if you could hit that arrow again. And all 3 of you put it in less than 1. Okay, why?
Because On 3 times 1/2, I did 3 times 2 is 6. Added the 1, it's 7. Then put it as the numerator. The denominator is 2, so it's just less than 1 whole.
So why did you multiply 3 times 2? Did you get that? Debbie got it. Joe is going to get it. Tell your neighbor what this little girl was doing. What is she doing? Yes, she is. Yes, she is. Raise your hand if you recognize what procedure she's using. Everyone whispered that procedure. Mixed number. She's trying to convert 3 times 1/2 into an improper fraction, right? Okay. All right. Ready for the second girl? Okay, Cammie.
So is there some rule you know about multiplying a fraction by a number, a whole number?
You have to multiply the numerator and the denominator by that whole number.
Okay.
I asked her, is there a rule that you understand about when you're multiplying a number by a fraction? And she says something about you multiply by the numerator and the denominator. So she multiplies 1/2 by 3/3. And that's why she put it in less than 1. So put that down, 3/3. Okay? So, last time we bugged you and we said, go back and ask big questions. Go back and make your children think. And did you go back and run into this? I'm asking big questions and everyone is like, silent or wrong? So my question is, what do I do now? So we're going to kick out of this for a second, and Cammie will come back to you, so don't leave.
How many people are kind of feeling Fran's pain with these 3 kids trying to figure out how to move them, right? So we're trying to get in her brain a little bit here.
So remember, these are kids from anywhere. So we're not condemning Elk Grove children in any way, shape, or form. These are my Davis kids when I taught in Davis. These are my San Juan kids when I taught in San Juan. I've had lots of jobs, so I could keep going, okay? But these are kids that are all over because we've been very heavy on procedure. And in all fairness, this is the end of the year, 4th grade. Okay? So talk with your neighbor just for a second. Why did the 2 little girls get it wrong? Why did they get it wrong? The other thing that we didn't sort of highlight is, and the 6th grade teachers brought it up, is that the first little girl also says, it sounds like she's flipping 2 and 7, so she gets 2 7s. Because remember, all 3 of them put 3 times 1/2 is less than 1. Okay, all 3 of them do that. Now, as I walked around and to this question, why did they get it wrong? I heard a lot of, well, they are just procedure heavy with no thinking. And we're not saying to get rid of procedures, no way. We're saying, though, we must balance it out with thinking so that kids can stop themselves and say, oh, that doesn't make sense, right? That's where thinking will come in. I was a student like them, just going to robot procedure and not question my answer, okay? So here we go. So as a teacher, when I'm thinking, plus there's a camera on me, I think, oh no, what do I do now? Right? And there wasn't just a camera on me. People were coming into the room because they heard I was there, kind of this, and you go, gosh, this is not my shining moment. Lock the door, right?
How many people are glad that doesn't happen to them every day?
Well, one of the things that when people ask what I do, I say curriculum specialist, and nobody knows what that is if they're not in education. I say, oh, I make public mistakes, and then I let people analyze them. So that's kind of what Debbie and I sort of do all the time, and this is one of them. So what do I do now? Let me give you a sense of what I was thinking. There's some connections that we can make back to that test that you took, that LMT test, that we want to grow that part of our brain. We want to build that muscle. What are the different strategies that we see? What connections can we help kids make? And I'm going to hit this idea of formative assessment. So I have seen in front of me, they don't get it. That's data. What do I do now? So that's the problem. I've seen the data. It's right there in front of me. What do I do now? Well, I could try to go back to something that they do know. And I would go back to the idea that multiplication is repeated addition. Okay? That's one. I'm trying to show you what goes on in my head. I have like 4 or 5 different options that I can play with. I could go back to this idea of fraction of the whole set, because if you look, we're asking what's 1/2 of 3, right? So watch this cool animation. I could do that. No, the next one's cooler. Or, so that's, both of these options are based in understanding and meaning, okay? I'm trying to make a connection for them. They know something, and I want to make a connection to something they already know. I could use a number line. And I could do, this is a lot like the repeated addition, but we could jump. We could jump in 1/2 jumps, okay? Or I could reteach the algorithm. Many times I've chosen to do that. Just trust me, guys. Just trust me. Just do this, okay? That's what my teachers did to me. A lot of times I've done that. But if I want to make a connection, I'm going to make a decision on one of these, okay? So here we go. You know, what if I just said, and I'm going to write on here, what if I said, and I don't care what the answer is. I don't care what the answer is. But what does that mean? Aiden?
The 3 times 2 means the x in the middle means you need is 3 times as many as 2.
Okay. So if I had 2 sandwiches, what does this mean?
It means the answer is 6.
Okay. So if I have 2 sandwiches, how many groups of 2 sandwiches do I have?
3.
So I could add them together 3 times.
Okay.
So, pardon me, but I'm going to draw. So here are my 2 sandwiches. Okay. So there's one group, right? And you're saying I can add 3 groups of them together? And what did you say it was, Aiden?
6.
Okay. All right. So I don't want us to forget this. So that we know, then we have 3 times 2. We could say 2 plus 2 plus 2, right?
Mm-hmm.
Is multiplication and addition related?
Yes.
How?
Multiplication and addition are related because you can all, if you put them in groups, you could like for that problem, because you put them in groups, the 3 times 2 equals 6, so you put them in the 2 groups of you put them in 3 with groups of 2, and then you added them together to get 6.
And how many times did I have to add that group of 2?
3 times. 3 times.
Oh, so that tells me I could add them 3 times. Okay.
Mm-hmm.
What if I looked at it the other way? What if I had a group of 3 things? How many times would I add it?
2. 2.
Oh, how did you know that?
Well, because you can, when you add 3 2 times, that means multiplication.
No, so I'm going to try that. So you're saying, so I have a group of 3 things. There's my sandwiches again. And you're saying again, how many times do I add it?
2.
Okay, I'm going to try that. And what should it be?
6.
Oh, sure enough, 6 sandwiches, 6 sandwiches. Okay, so we know something about multiplication, right? So let's use what we know to deal with this fraction one. Okay, so I'm going to write the one you did, 3 times 1/2. So, what does that mean I should be able to do? If you know about multiplication, you know something about multiplication. How could I relate it to addition?
You could relate multiplication to addition because you pretty much, you're adding in multiplication and you're also adding in addition.
So can I do that when there's a fraction?
Yes.
Seriously?
Mhm.
Okay, so what am I going to add?
You are going to add 3 times 2
We already did that.
But
Three
but
times
that's
one.
multiplication.
3 times 1.
I thought I got to add something. Remember over here, you told me I could add groups of 2, I could add 3 groups of 2, or I could add 2 groups of 3. What can I do here?
You can add 1/2 plus 1/2 plus 1/2.
Why?
Because you add 1/2 3 times. It's 1/2 times 3.
We better try that out. Okay, let's try that. So Sophia says 1/2 plus 1/2 plus 1/2. Holy smokes. What do you think that is?
1.5. 1 whole and 1/2.
1 whole and 1/2? How'd you get that?
Because 1/2 plus 1/2 equals 1 whole, and then 1 whole plus 1/2 is 1 whole and 1/2.
Do you believe her? Aiden doesn't believe her. So how much is that, Aiden?
It's 3 6.
Why? How'd you get 3 6?
You added 2, 2 and 2, which is 6. 1, 1, 1, which is 3.
Oh.
3 6.
How much is 3 6 then? Because she says it's 1
3
1/2.
6 is 1/2 of a whole.
Oh my. So she says 1 1/2 more than 1. You say 3 6 is less than 1 because it's half. Okay, we better put it, you might be the deal breaker here. Okay, so we're going to put it in a real situation. Okay, you ready? So I have 3 half sandwiches. I have 3 half cookies. I have 3 half pizzas. I have half of something and I have it 3 times. What do you like? Shall we talk cookies? So picture it in your mind. I have 3 half cookies. You see a half, and a half. I have 3 of them. Half, 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 like Sophia said. How many cookies do I have altogether?
2.5.
Oh, 2 1/2. What do you mean?
Because you have 3, because that.
My stomach's growling. Holy smokes, I'm thinking about those cookies. Go ahead.
And because if you add two halves together, that would actually equal.
We better draw a picture. Let's draw a picture, okay? Ready? Draw the picture of the 3 half cookies. Go ahead, Aiden. Draw it on your paper. Draw those 3 half cookies or 3 half sandwiches, whatever. Okay, Aiden, what did you draw? Because we're trying to draw this. Half cookie, half cookie, half cookie. Okay. So, tell me about your picture. Where's the half, and the half? Okay, where's the half, and half in your picture?
Half, half, and half.
Yeah, half cookie, half cookie, half cookie. Oh, so show me the 3 halves. Where are they? So did you take this cookie apart?
Mm-hmm.
And where is it down here?
Right here.
Okay, and then where's that half?
Mm-hmm.
Okay, so let's see what you've got. Oh, look, she has the same thing. Oh, look. So now I wonder how many cookies is that? How many cookies do you have?
3 halves.
And how much is that? What'd you say?
1.5.
1.5 what?
Cookies.
1.5. So 3 halves is 1.5. Where did you all put 3 halves?
Less than 1?
Is it less than 1?
No.
Oh, no. You want to switch it?
Yes.
You can switch it. Absolutely. This is where it's too bad we're on marker. But I like to keep my mistakes so I can see what I did. So right now, talk with your tables about what you noticed me, teacher mode, doing, and did I get to a good spot? So chat with your tables about it. So we'll put Debbie on the microphone. Debbie, are you ready?
I'm ready.
Let's open this discussion. Who'd like to throw something out to the discussion that they noticed, something that they have a question about, a statement they want to make?
And what were we just talking about again?
We were just talking about teacher moves in there and that questioning idea. We over here?
Pardon me.
We were just mentioning that it was really good how you took whole numbers and had them multiply those first and then relate what they knew about that to the fractions.
Okay. Debbie said something earlier about, what did you say about mathematics is just, it's a whole bunch of connections that kids don't see.
Well, and sometimes I think when we start teaching fractions, kids start thinking this is a whole nother thing.
Right.
And what we want to do instead is have them build on what they know about arithmetic with whole numbers to recognize that fractions are numbers too, and they work the same way. So it's a very valid point. She went to hoping they knew multiplication with whole numbers and was able to then, okay, so how do I bring that to bear? That was her question. So what would multiplication of 3 times a half look like?
Okay. So the whole idea is if my kiddos can understand that they know something, then they can make the connection and they can use a strategy that makes sense. They know if they're right or they're wrong. But when you're only doing procedure, when the classroom education is procedure heavy, they see it as random, different pieces that don't connect, unconnected pieces that go into their head. And our job is to connect, and connecting is thinking. Okay, because they can use what they know. Another comment or? Yes.
You flipped the order. You know, you said you just did the old 1/2 of 3, and that made a lot more sense than 3 times 1/2. So.
Well, and I thought about, because did you notice when I was doing the whole numbers, I talked to 3 groups of 2 and 2 groups of 3. We could have talked about this idea, which is easier, 3 halves or half of a 3. And talk about that and see what they would talk about, how they could sort of make that connection. Okay? Other comments, questions, statements?
Here's one back here, Fran. You got one over there? You go first. Okay.
I was just thinking that maybe this conversation could have been started with a different question rather than which one's more than one. Can you draw a picture of what this means? Because I think a lot of the symbolism totally confuses the kids. They think they don't understand the language. And so connecting that, and when you eventually got to the pictures, I think that was beautiful because the kids needed that. Tell me what this looks like in cookies.
Right.
And getting there, having them think about that, then all of a sudden the light went on, I think.
Right. Well, and we didn't want to change that SBAC item at all. So we gave them the item that was on the field test. And so by the end of 4th grade, so in all fairness, this is the end of a 4th grade problem, they have to be able to make sense of that. Now, if you're completely procedural and you do the procedures correctly, you can answer that problem. We ran into some problems with kids who weren't quite solid on the procedures yet, and we wanted them to kick in and think and say, oh, no, that can't be reasonable. Debbie?
So the other thing to think about there is those 3 kids actually learned that they can do that problem through the course of that. Now they realized probably that Fran asked them a couple questions, but I'm going to hazard to guess that they're going to have perhaps a little bit different mindset when encountering another problem, because they'll realize, oh, I don't just have to think about it one way. I remember that day when I was hanging out with my 2 buddies and that lady named Fran, and we worked through the problem a little bit and drew pictures, and we thought about whole numbers, and so they have that first chance of doing some perseverance. So sometimes we can ask the bigger question. We just have to be ready as teachers with, if they're really, really totally stuck before they start crying. Yeah. We don't want anybody crying, right? But before that, they get a little struggle, but then they realize, okay, so now I'm going to intercede, and then Fran came up with some ways to do that. So we have a balance to make so that they realize that they can actually do it.
And I think that's the good news of this little clip, is that we had kids who look like kids in your room that tried a procedure and then ended up thinking about it and knew if they were right or wrong. So, I mean, the hope is that everyone can do that. I mean, I believe everyone can do that. We just have to be the ones leading the pack.
I was just wondering if anybody can tell me where that particular algorithm was taught, because we didn't have 3/1 that I saw.
I probably just skipped it.
What algorithm?
The Go Math.
3/1. Oh, I don't know. It's not taught in Go Math? Oh, good. Then you don't even have anything to undo, maybe. So, well, sometimes, I mean, I don't know where it's taught. It's multiplication of fractions by a whole number is a 4th grade thing. Okay? but it's 8 times 5, 6. Oh, they don't tell them to put it over 1. Well, the good news is you can. Oh, they do in 5th grade, okay? Well, I would talk about it in 4th grade too. Or I might just go back to they made. Long ago when I was in the midst of Math Their Way, and some of you are old enough to know about that. Some of you might have been in Math Their Way classrooms as children. We used to talk about, there was a big guru at the time, Kathy Richardson, she's still around, but we used to talk about finding that edge of understanding. And that has stuck in my mind for 25 years, this idea that I'm that kid detective and I have to go back to the last place they understand. That's where I bridge it. Sometimes it's easy, sometimes it's not easy at all. My questions fall flat, I can't find it, so I have to table it, go talk to a colleague, and come back. But my job is to really find, because I'm in charge of making the connections. I'm in charge of finding kids who have made the connections so they can share that. Because if you can't make connections, you're like little Fran, freshman at UC Davis in Calculus 16A. I'll never forget it, who said, I can't do this. And I had to change my major. I can't do this anymore. I have no more room for unrelated information. It's gone. I've tipped off. And I used to try, bike school, right? So when I had a final in calculus, I would put my hat on, put my hood on, even if it was 80 degrees out, ride my bike and not talk to anyone because I felt if you talked to me, you would mess up all that stuff in my head that I needed to kind of regurgitate out on the test to get the grade.
Wait.
Obviously, it
How
didn't
many
work.
other people passed a final exam doing that very same thing?
Don't talk
you
to
guys
me,
lie.
you'll mess it up. Now, if I understood it, there's no way you could mess it up because it's mine. I own it.
So I would argue that we even saw a tiny glimmer of that kid on this video for whom Fran had to go back a little further in finding the edge of understanding. Yeah, there was a kid that was kind of on the top of the screen, and there was a kid on the left of the screen, and there was a kid on the right of the screen. So which kid do you think Fran had to push farther back in understanding? Go ahead and point which way. I'm seeing most people point that way, the little boy, right? I'm thinking she had to go back a little farther to find his edge of understanding, and then she was able to work him back up. Now, I don't think he probably mastered it yet, but she's got some place where she can start building from here, or the teacher could, so.
My question was, for these students, Fran, in working with them, you said that some of the students, you can tell, do not have a mastery of the procedure. And I know that some of my students have the procedural knowledge, but the procedural knowledge leads them to an incorrect answer because they use the procedure in an incorrect way. And so my question is, in your experience, or y'all's experience, who is the more difficult student to teach or for them to acquire the proper way to do it? Is it the student who has a lack of procedural knowledge and is now learning how to do it the correct way with the correct procedure? Or is it the student who has learned the procedure but didn't quite understand how to work the procedure and then is kind of mixed up? Is it like the whole Yoda, you must unlearn what you have learned kind of thing?
Well, I think that's such a cool question. I want you to ponder that for a second. So that's an age-old debate from teachers like me, like you, who've tried to get more thinking in. You think, what do you do first? Do you do the thinking and build up to the algorithm, or do you do the algorithm and go backwards? The Common Core, let's do it. Okay, show me on your fingers, where in the Common Core, and I don't know if I've done this, you have the right answer. Where in the Common Core does it say, must learn the algorithm for division? Must be able to do the standard algorithm for division. Show me on your fingers. What grade?
You wanted them to show on fingers,
I
right?
want
So
you
they
to
should
show
all
me
be
on
raising
your
hands
fingers.
and
Come on,
showing what
let's see
grade on
some
fingers.
fingers.
Long division, where do you think it sits?
Okay, there are people who know. Everyone look at Joe in the back. 6th grade.
Whoa, I thought it was 4.
Show me on your fingers where the standard algorithm for multiplication is. So the Common Core answers your question. It says build understanding, then show the algorithm, because the algorithm essentially is a shortcut. The problem is it's no child's shortcut, because they don't understand enough to do a shortcut. Okay? So the next problem that we did, and I've only got like 30 seconds, is that wasn't the end of the session. We said, okay, what about 5 times 1/4? Because that's on there too. So very quickly, 15 seconds, talk to your neighbor about how do you think we approach that. So guess what happened? 5 times 1/4 was in less than 1. The kiddos didn't even have to think more than 10 seconds, and they changed it. Okay? So it's kind of like what Debbie just said. We interject a little bit of thinking into it, then they can easily fix 5 times 1/4. That was not hard at all. Okay?
How many of you got the email from Kara or got the handout last time with the 3 colors on it, red, green, and yellow? All right, it was the stoplight thing, trying to think about and reflect about what we're doing for our own practice. So if you'd pull that out if you have it. If you don't have it, your neighbor probably has one, and you're going to talk about it anyway. But I'm going to give you some directions in about 5 seconds. Pull out your thing and then give me your attention in 5 seconds. All right, so you should have your paper out. That was 5 seconds. How many people saw me counting 5 seconds? All right, cool. So, what we asked you to do last week, and we're going to have you share what your thoughts were, was red's what you're going to stop doing. You were supposed to think of at least one thing. Yellow's what you want to refine or change. And so if you didn't have a chance to do this, and this is the first time you're thinking about it, you got this a little bit of time to think about it while I'm reading these directions. Green's what you want to continue to do or deepen or refine or something like that. I'm going to keep on doing that. What I'm going to have you do is now this is the challenge. Everybody's going to, and I'm going to adjust those directions up there. Whoa, I walked right out of my shoe. How many people know which people saw that? Yeah. Camera, you got to get close up here. I'm not going to have you stand with triplets. I'm just going to have you find one other person that you do not know. So I'm going to have you just make some eye contact with somebody across the room that you don't normally talk to. And so right now you're making eye contact. You got about 30 seconds to make eye contact with somebody. You got to do this little thing. Don't go anywhere yet. Just make eye contact. All right. So you're going to find that one person. You have to actually stand up, go somewhere, and you're going to share what you did for red light, green light, yellow light. Now that's after, of course, you introduce yourself and find out the grade level of the person you're talking to. So I'm going to give you 5 minutes where you stand to share what you were doing between last week and this week. 5 minutes. Who would like me to repeat those directions? Okay, here goes a repeat of the directions. Wait. Pause. You're doing great, but stay right there. That's fine. Just freeze right there. You're going to find your partner that you just made eye contact with, and if you're a person that didn't find a partner, you can come right up front here and we'll partner you up. I'm going to be looking for you. All right, share your red thing, you're stopping. Share your yellow thing that you are changing, and your green thing. Go.
For the red light, what I wanted to do is stop asking easy leading questions. I really felt like I needed to stop doing that and to really concentrate on how to ask the better form question. For the yellow light, I wanted to work on asking questions that require a depth of thinking. More content-driven, really having the student think and stop and ponder and work on that. And for my green light, I really want to work on deepening my own feelings of how to instruct fractions curriculum.
Yeah, for my red light, I said I needed to stop trying to teach the lesson on the fly. Coming into the classroom, opening the book and saying, well, what do we got today? Because if I do that, then I can't really get enough depth of a lesson on my own to help the kids create a better depth as well. You know, I'm just making things up as I go. For the yellow light, it's kind of like your red. I can't really commit just now to totally stop those leading questions cold turkey, but at least be more aware of them, start slowing down, you know, toning them out. Yeah, because I know I still have a lot of that kids that just don't have the depth, like that kid we just saw.
There's something else. Oh, I'm sorry. There's something else I noticed with English learners. 3 halves, and those words can sound an awful lot alike when you're using them in math terms. And if you're an English speaker, you have to really listen carefully to those terms and think if you're an English learner, how some of those fractional terms can come off.
And then for my green, it's kind of white with the red. If I'm looking into the lesson early, then I can start developing those DOK2, DOK3 questions to prompt the thinking and make the kids more aware. And then that will really help me to understand who are my non-starters versus the kids that actually get it, and really start to differentiate where they are on the spectrum of learning and get them going.
So you really know the students, so you can do starts with them or choose 3 ways, or all those different strategies.
And a lot of times we assume we know who the smart kids are and who the non-leaders are, but it could be that a kid actually understands the strategy. But how do I know if all I'm doing is giving them leading questions?
That's right. Let them, I love letting them explain. I love letting them talk to each other and let them tell what it is they know and how they know it.
So in going forward, set yourself some new challenges, or if you need to continue, set a new red light thing, or if that's still a red light thing you want to keep working on, write that down. We're going to invite you to save these red light, green light papers, and you can watch your own thought process over the course of this year, maybe next year. So we're going to give you some quiet time to identify a new red light thing that you plan on stopping doing. You can be thinking about what you're teaching this month. A new yellow that you want to change. A new green that you want to keep doing. Or maybe you've decided I need to continue working on something that I did before. That's cool. And so now I'll finally shut up and give you some think time to write that down on that paper for yourself. So now that you shared, how many people like stories? How many people like stories? So this is a good teacher story. How many people know my friend Joe over here? How many people know him now? All right, so Joe's got a story about 3 times a half.
Yeah, so after I watched that video, I went home and I used my daughter as a guinea pig. She gets to be my math guinea pig all the time, so I always run home with these new math things and say, hey, try this out, Heather. So I gave her that problem 3 times 1/2, and I asked her to solve it. First thing she did, she looked at it. So, okay, she drew 3 circles. I'm like, okay, she's getting it. And then she took those circles and she split them in half. I'm like, okay. And then she counted them and says 6. 3 times 1/2 is 6. I'm like, okay, Heather, let's look at it this way. Flip the paper over, and I put 3 times 5. I followed what Fran did. And she showed me a model representation of 3 times 5, drew 3 circles, put 5 in each one, and I asked her the relationship. I said, okay, now turn it over. Now let's look at the original problem, 3 times 1/2. And she's looking at it, and she's like, oh, okay. So she shaded in 1/2 of each circle. And I said, okay, now what's 3 times 1/2? She's like, 3. I'm like, okay, we're getting closer. All right, so I'm okay, Heather. So now you've decided you've got a half in each circle. You got 3 groups, 1/2 in each group. Let's move those halves out of those groups and draw them separately. So she, like that young boy up there did, she drew each half, 3 halves, looked at it and said, oh, 2 halves make 1 whole, so I have 1 whole in 1/2. So it took her those steps, and I followed what Fran did, and it took her those steps, and when she saw use the model, she saw that connection.
So we're going to shift gears a little bit from math focus to our PLC focus based on some of your evaluations, and what I've been hearing being out in the schools is that there's greater needs. And so what I would like you to look at is this quote and think for a second how that applies to us and to the work that we're going to be doing. So for us to be able to have greater collaboration, we wanted to address where we've been and where we're going. So up to this point, you are leading the way of Common Core Math implementation through your PLCs. And so we want to look at the skills that we are giving you or helping you to hone is, first of all, our professional development for you. And the two areas that we've been focusing on is the content and the strategies. And so what we want to focus on today is look at personal development. You have professional development. Now we want to look at your personal development in terms of what skills do you need or can we provide you with to be more effective as a PLC leader. And so we're focusing on two things, both facilitation and leadership. And so we're in the process of planning for next year and being able to really look at how can we best meet your needs to develop the skills in your repertoire to be able to be as effective as possible in leading your PLCs. So here's what we want you to be thinking of, and we'll do this in a few minutes after a group activity that we're going to do. And this is what we want you to be thinking about. By next year this time, what do you hope to accomplish as a PLC leader and facilitator? So you don't have to write anything right now. We're going to address that in a few minutes. And then how can Math Generation support you in developing facilitation skills and your leadership skills? So in order to do that, I'm going to show you a few examples of what we were thinking about. I would like to be able to know how to inspire people to take on new challenges. Are there skills that you could learn to be able to motivate other people and inspire them to take risk and try something new? I want to be able to hold effective meetings where people are excited to share and grow as educators. So what are some of the things that we could do to empower you to be able to be an inspirational leader? And I want to become proficient in math strategies and be able to openly model for my colleagues. How wonderful would it be if we could do peer support? If we could have your team come in and watch you and then them go back to their classroom and try to do that. And by the way, the Number Talk books have come in. I'm halfway through the district, and so tomorrow I'll be trying to hit the rest of the schools. And so once they go through your library system or however your school checks out book, you'll all have those by the end of this week. So here's what we want you to do. We're going to do a group activity, and while I'm talking about this, the team will be passing out the papers that I need distributed to your tables. So here's what we want to do. We want to think global. And when you think about what we're planning for next year, we want to look at all of these opportunities that we can think about in terms of us helping you meet your teachers' needs. We have 1,400 teachers that Math Generation is supposed to impact. And so we want to be able to listen to you, find out what you need from your school site, be able to look at how we can equip you and train you and give you those skills to be able to do that. So here's what the task is. You're getting a paper right now, and it has directions on the paper. And so what you're going to do with your table groups is you're going to read the directions and complete the task. For the first 15 minutes, we want you to go through each one of those and have a conversation about what does that mean, and do any of them apply to your table or your school? And if you go, this doesn't pertain to us, our school's good, we don't need anything, that's great. Because what we want to do is have you go through this list as a global view and be able to then, personally, you're going to choose your top 3. The ones that you go, I want to prioritize, what do I need for my site? What do my teachers need that I really want to be able to be trained or have skills to be able to facilitate that? So you're going to write those 3 down on sticky notes. That's why there's so many sticky notes on your table. Is the 3 that you have, that you're going to ask for support and tell us what you think you need. How can we meet that need? And then around the room, the first half of the room, the front side, there's all of the 12 items up here plus one other. And then for the back of the room, across the back, there are the same 12. And so here's what we're hoping, is that first you have a conversation about what do teachers need at your site. And you listen to what everyone's talking about. What do they mean? What does this mean? What do we know? What are our teachers needing right now? And then after that, I'll give you a signal, and you're going to take your 3, and you're going to say, if in all the best situation, what can we do to help you meet that need of your teachers? Because all of you have anywhere from 2 to 6 people on your team. And sometimes you have multiple grade levels because you have limited PLCs at your site. And so as you think personally, what do your teachers need? How can we meet that need? And then that will translate over into your goal that we will come back and revisit at the end. So are my directions clear? So everyone understands. We're going to have about 15 minutes of talk time going through each one of those at your table groups. Then you personally will choose 3. On your sticky note, you're going to write down, how can we help you? What do you need to be able to meet that need? And then I am going to synthesize this information to be able to look at how are we going to look at our professional learning for next year. Because it won't be this big of a group next year. We're going to break it by grade span so we can more specifically meet your needs, whether it's K2, 3, 5, 6, 8, so that we really can meet your needs more holistically and specifically. So be thinking about what is it you would like us to provide you with. Okay, so take 15 minutes with your table group. Beautiful. So walking around, I heard some incredible conversations about what your needs are. So now, as a school site PLC leader, personally, I want you to take and look at the chart and choose 3 of your top priorities. And then on the sticky note, you're going to put, what do you need in order to meet that need? What do you need from me in order to do that? For example, someone said, I need my teachers on my team to be able to see me, which is very vulnerable and risk-taking, to see me do a number talks lesson with my students so that they understand what number talks is all about. In order to do that, they said, I'm going to need to have release time for that person to be able to come in to see me do that. So that's what your need is. You need to have the ability to have the teacher released with a substitute teacher to come watch you do a 20-minute number talks. And if we coordinate, before you start talking and going, oh my gosh, freaking out, listen carefully. If we coordinate that by school, and I have a sub and I bring them over there for you to be that peer support model, then I can have the sub with me for the day, and all of you would be able to do those kinds of things. But we have to know, number 1, you're willing to do that. Number 2, that your team would be willing to come in and watch you teach so that you could have that conversation as part of your PLC. And so think specifically about what is it that you need for your team to be able to be part of your group by coming together. Do we need more Saturday seminars? Do we need to have more opportunities for regional trainings? I mean, what do we need? And you're going, are you kidding me? One's enough. But I'm just saying, as a district, I'm looking at it from a district point of view, from a math generation point of view, and being able to really look at, we have 5 years. How do we want to spend our time? Okay, so now here's what your task is. Get your 3. You may put your grade level if it's specific to grade levels. If you want your school site on there so that I know what your school site needs are, then put that on there also. Or if you just want to put your name on it so I can contact you. But then you're going to go to one of the charts and place yours up there, and then take about 7 minutes to do that. And then we're going to come back and we're going to focus on our goal writing, okay? So go ahead and go. When you have your 3 sticky notes, get up, go, and stretch for a minute, and then we'll come back together. All right. Wow,
I love the energy in the room. I love the work that you've done. This is very exciting. Listening into some of the conversations and what you're choosing that you need is so powerful. And you're also, some of you have put up obstacles. And you know, an obstacle can be removed. And that's my job and Kara's job, is to be able to look at the obstacles and how can we remove those. And so we want to be able to feel the pulse of this room, hear what your hearts say, and be able to move forward, because we really believe that Math Generation is going to impact the next generation of kids. We believe that, or we wouldn't have done the work that we did. So here's what I want you to do next. We have about 12 minutes, and then Kara's going to come up to close the day. And here's what I want you to be thinking about. The conversations that you had at your table about what you believe your school needs, your teachers need, and then you shared ideas across district with your colleagues that you're sitting with. Now I want you to focus on yourself, because we tried to focus on your team, your school, and now we want you to focus on you. And so here's what we want you to think about. By this time next year, you have a team goal, and you're going to, on the front side of the card, I want you to write, what's your team goal? And then on the back side, I want you to write, what's the most important you need that we can help you with? Okay? So we're going to take, and then you're going to leave your cards on your table. So the first one is, what do you hope your team will accomplish? The cards should be on the table. Oh, Joe, they're on the back table. Yeah. No, I have 3x5 cards that I want you to be able to leave on the table for me. Now, can I have your attention for a minute? Apologies. The cards are coming. The reason we put them on the back table and didn't pass them out till now is because mathematicians like to work problems on paper. We learned that from Mr. Freethy. Every time we work with him, he wants a pad of paper. So here's what we want you to do. Front side, what do you hope your team will accomplish? You as a PLC leader, what do you hope your team will accomplish by this time next year? And then, what is your personal need for Math Generation to be able to support you? We are going to collect these cards. You do not have to put your name on them. If you want to, that's great. If you want to put your school, that's great. But we don't want your names, because we don't want you to influence what you're going to write. We want you to be completely candid and honest. Yes?
Do you mean our team, like our PLC team, the other people we're here with, or the PLC team we guide?
Your PLC team that you guide, first and foremost. If you also want to hopefully set a team for your whole PLC group, you can put that down as a sub-bullet if that's one of your goals. But I just want you to commit. When you write something down, I want you to commit to the goal, because then when I read these goals, what's Kara and my job? Our job is to help you meet your needs and your goals. And we want to try to do that.